Good morning, dear students. Today is our fourth practical lesson. On previous practical lesson, we were integrating trigonometric functions, no, trigonometric expressions, and also used trigonometric substitution for irrational functions. Our topic for today is definite integral. Formula is the following. So we calculate with the Newton-Leibniz formula. We find first of all antiderivative, and such record means with the substitutions from A to B. That means that we calculate f capital from B minus f capital from A. Now we don't add constant because anyway it is eliminated, so doesn't make sense. And here is a formula of integration by parts for definite integral. So we use the substitutions for product over u and v. So it is similar to indefinite integral, but we start using substitutions, so it doesn't make sense first of all calculate antiderivative and make these substitutions, so a little bit simplified. And now let's start calculating integrals. So we will use techniques, approaches that we used before. The first integral is the following. So from 0 to 1, square root from 1 plus x dx. So this is the table integral. Actually, yeah, we will use the differential entry technique. So it is the same if I write a differential over 1 plus x. So, according to table of integrals, we have the following integral 2 over 3, 1 plus x multiplied by square root of 1 plus x, and with the substitutions from 0 to 1. So 2 over 3, and now substituting 1. So 1 plus x, so 2 square roots of 2 minus 1. So this is the final answer. Yeah, Maxim?
Why do we have 2 over 3, but not vice versa, 3 over 2?
Okay, let me explain you. Let me remind what's going on. Let me remind you.
Because we have a square root, 1 over 2 plus 1, it will be 3 over 2.
Yeah, let me. Yeah, but we divide by the degree. So let me remind you table. So this is integral from the table. So the following. So 1 over alpha plus 1, and here it is also decreased. And so here we have 3 over 2, but we need to divide by it. So 2 over 3. Have I answered your question?
Yes, thank you, I see.
Yeah, so be attentive. Okay, more questions? Okay, if no questions, let's move to part B. Integral from 0 to 2. So x divided by x squared plus 1, and this expression as well is power of 2. So in the numerator, we have a differential of this expression, so half of the differential. So let me, oh no, let me write it. So in details, so 1 over 2, and here 2x dx. So now I can write the numerator as a differential of this expression. So dx square plus 1. And now we will integrate. So minus 1 over 2, and the antiderivative is the following: 1 over x squared plus 1, with substitutions from 0 to 2. So calculating it, minus 1 over 2, and now calculating this expression. So no, so 1 over 5 minus 1. So 1 over 5 minus 1 equals minus 4 over 5, and minus 4 over 5 by minus 1 over 2 equals 2 over 5. And this is the final answer. Any questions about this exercise? Okay.
No.
If no questions, let's move next. C. So the following integral from 1 to e, 1 plus logarithm of x, but that's not natural logarithm, but a decimal logarithm. So pay attention to it. So again, use differential entry technique. And how do we use it? So differential over 1 plus decimal logarithm of x will be equal to natural logarithm of 10 over x dx. So yeah, if I'm not mistaken, we divide. Oh yeah, so we need to divide. I forgot a little bit. Yeah, when we differentiate logarithm, we divide by natural logarithm. So logarithm of 10 and multiplied by this integral, yeah, and here we also need to divide by 10, by logarithm of 10. Correct, but now correct. Okay, now let's and on the differential. So now we received the differential of 1 plus decimal logarithm of x. And now we can calculate this integral. So don't forget about this coefficient, and we divide by 2, and we have 1 plus decimal logarithm of x in power of 2. with the substitutions from 1 to e. So calculating. Okay, do like this, and then so the first so 1 plus decimal logarithm of e in power of 2 minus 1 minus 1. Yeah, because a logarithm of 1 and so either decimal or either another logarithm is 0. So it will be equal to 0. Okay. So now let's expand brackets and simplify it a little bit, as much as we can. So 1 plus 2 logarithms, decimal logarithms of e plus square of logarithm of e minus 1. And I can just eliminate 1. And yeah, I can also move logarithm of e out of brackets, but we can leave it like this. So we found the integral, so this exercise is done. Any questions about this exercise?
Could you scroll up a bit, please?
Yes.
Thank you. No questions.
More questions? Okay, if no questions, let's move next. Exercise D. We have the following integral. So e in power of 1 over x and divided by x squared dx. So here we have differential of 1 over x, but minus differential. So let's use as well differential entry technique. Yeah, and this integral will look simpler that it looks now. So differential of 1 over x. And we have minus e in power of 1 over x with substitutions from 1 to 2. Okay, and interesting what's going on here. Here is a mistake, by the way. Okay. We'll correct it. So, but now calculating this integral. So what do we have? So e in power over minus 1 over 2 minus e. Oh, stop. E in power of 1 over 2 minus e. And that's it. So this is the final answer. Any questions about this exercise? So it was quite short. Okay, let's move to E. The following integral. 4, 9. Okay, here is variable y, but anyway, it doesn't matter how it is called. Okay, now I suggest use formula of difference of squares. and simplify it a little bit. So we can cancel square root of y plus 1. While remove brackets, we actually need them. Now calculating the integral, so according to the table, and what do we have? So 2 over 3 y square root of y minus y with substitutions from 4 to 9. So calculating it. So 2 over 3 multiplied by 9 and multiplied by 3 minus 9 minus so 2 over 3 multiplied by 4 and multiplied by 2 minus 4. So now let's expand these brackets. So what do we have here? So so we can cancel 3, so 18 minus 9, so 9, and here minus 16 over 3, and plus 4. So we have 13 minus 16 over 3, and the final answer will be, so 39 over 3, 39 over 3 minus 16 over 3 will be 23 over 3. So this is the final answer. Any questions about this exercise? Okay, as I see, no questions. So let's move next. Now we will use the formula of integration by parts. So it's time to review it. So as you remember, as u here we take a polynomial, so the polynomial is just x. So u equals x and du equals dx respectively. Then dv equals e in power of minus x dx. So v equals minus e in power of minus x. And now use the formula of integration by parts. So with substitutions from 0 to 1. And so now we subtract integral from v by du. So plus, because of minus here, so minus integral from 0 to 1 e in power of minus x dx. So calculating everything in parallel. So minus x, so when we substitute 1, so minus e in power of minus 1. And when we substitute 0, just 0. And minus e in power of minus x with substitutions from 0 to 1. And yeah, so what do we have? So e in power of -1 minus e in power of -1.
Where x probably -1.
Oh, sorry?
Near. Not e in -x, but e in -1. Yes, here.
Here, but with
I
substitutions, yeah. So here is the antiderivative. So
yes, I see.
yeah, and +1. So just for better record, 1 minus 2 over e, and this is the final answer. Any questions about this exercise?
No.
Okay, no questions, so move next. So we have the following integral from 0 to p, and so x cube sine of x dx. Again, this integral is taken by parts as well, and we have, so according to power of 3 for x, we will have to apply this formula 3 times. So let's do it. So first of all, so u equals x cube, and then du equals 3ax squared dx. dv equals sine of x dx. So v equals minus cosine of x. And now let's apply this integration by parts formula. So minus x cube cosine of x with substitutions from 0 to p. And plus the following integral, so 3 of x cube square cosine of x dx. Yeah, substitutions from 0 to p. Now let's first of all calculate this expression, and then we will move to calculation of this integral. So when when x equals p, so p cube by cosine of p by -1. So p cube and -0, because this cosine will be multiplied by 0. So we have this expression equals p cube. And then plus this integral. So now we can continue integration by parts. So now u equals x square, du equals to x dx, dv equals cosine of x dx, and v equals sine of x. So we have the following expression. So x square multiplied by sine of x with substitutions from 0 to p. And minus the following integral. So from 0 to p. And yeah, let's move 2 out of brackets. So x cosine of x, x sine of multiplied by sine of x dx. Okay, first of all, calculating this expression. So when x equals p, this product equals 0. When x equals 0, this product also equals 0. So this expression is equal to 0. So we have minus 6, this integral, multiplied by this integral. So now use again. So last time we use formula of integration by parts. So last time, of course, for this exercise. So u equals x, and then du equals dx, dv equals cosine, not cosine, sine of x dx. So v equals minus cosine of x. So minus x and I lost p cube everywhere and nobody told me about it. Yeah, so when doing your individual home tasks, always be attentive. So don't lose any multipliers as I did now. So it was a bad idea to lose them. So minus 6 so x multiplied by minus x multiplied by cosine of x with substitutions from 0 to p. And finally, plus integral so again from 0 to p from cosine of x dx. So calculating all these expressions. So this expression will be equal to p. So when we substitute p, so p multiplied by minus 1, and here is minus, so p, and when 0, this expression is equal to 0. So p, what is going on? So p minus, oh no, not minus, but plus sine of x with substitutions from 0 to p. And this sine, so sine of x with substitutions from 0 to p will be equal to 0. So final answer, p in p cube minus 6p. And that's it. Any questions about this exercise? So quite a lot of calculations. Yeah, I know. But finally it's done. Okay, if no questions, moving to the next. So again, we will have to integrate by parts, but there is another case. So we will calculate integral from a natural logarithm. And how to calculate, how to integrate logarithms by parts. So reminding you that we select a logarithm as u. So du equals dx over x plus 1, then dv equals dx, and v equals x. So now integrating x multiplied by logarithm of x plus 1 with substitutions from 0 to e minus 1. And minus the following integral. So from 0 to e minus 1. So x dx over x plus 1. So now let's first of all calculate this expression. So e minus 1. Okay, so e minus 1 multiplied by logarithm of e minus 1 plus 1 and minus 0. Because of 0 here, and actually logarithm of 1, so as well. Here we just have e minus 1, because it will be logarithm of natural logarithm of e that is equal to 1. So done with this. And now we're calculating this integral. So let's transform it, by the way, because here we have incorrect fraction, and we just need to extract so we need to extract integer part from it. One plus x over x plus 1, and minus 1. So nothing was broken. And now rewriting this integral with the correct fraction. So minus x minus 1. So we have this fraction. So nothing was broken. So if I add 1 to this expression, we will receive x over x plus 1. So now we can integrate. So e minus 1 minus x minus logarithm over x plus 1 with substitutions from 0 to e minus 1. And by the way, I don't write module here because I know that argument of the logarithm is always positive, so it doesn't make sense to write it. But of course, if you want, so e minus 1 minus, so let's substitute e minus 1 and minus, so when I substitute e minus 1 here, I just receive 1. And if when I substitute 0, I will receive everywhere 0. So that's actually what we have. And here, so e is eliminated, 1 is eliminated, and the answer is 1. Any questions about this exercise?
No.
Okay, no questions. So let's move next. The next exercise, so we will solve it using another approach. So we will rationalize the integral with the substitution. So we have irrational function here. So 9, then so square root of x, and square root of x minus 1. dx. So let's make the following substitution. I suggest substituting square root of x minus 1 as t. Then x equals, so square root of x equals t plus 1. So x equals t plus 1 square. Then dx equals 2t plus 2t plus 1 dt. Then when x, so we need to do something with bounds of integration. When x equals 9, t will be equal, so according to this expression, t will be equal, so square root of 9 minus 1, so it will be equal to 2. And then when x equals 4, t equals 1. So when we substitute here, so square root of 4 minus 1 equals 1. And now we rewrite in the rationalized integral with the new bounds of integration. So so t plus 1 over t and multiplied by 2 t plus 1 dt. So I will move 2 out of the integral sign, and I receive the following expression. So it will, so we have t plus 1 square. Then I will expand the brackets. T squared plus 2t plus 1 dt. And now continue expanding, so divide everything by t. So t plus 2 plus 1 over t dt. And finally, we find the antiderivative. So 1 over 2 t square plus 2t plus natural logarithm of t, again without module sign, because we know that it has only positive argument. And now let's calculate. So 2 multiplied by, so by the following expression. So 1 over 2 by 4 plus 4 plus logarithm of 2 and minus 1 over 2 plus 2 and plus 0. So now continue calculation. So here, so this is, so it is equal to 2, and this expression, so 6 plus logarithm of 2 minus 1 over 2 and minus 2. And then I divide and I multiply by 2. So okay, first of all, let's also calculate 6 minus 2. So 4 here, and then we will expand the brackets. So a equals 8 plus 2 logarithm of 2 minus 1, so 7 minus 2 logarithm over 2. Any questions about this exercise?
No.
Okay, so move next. Let's calculate one more exercise related to substitution of variable, and then we will have a break. So integral from 3 to 8, and the integrand is the following. So x over square root of 1 plus x dx, and again we do the substitution. So the substitution is the following. So we substitute all this expression under the root as t. Then x equals t square minus 1, dx equals 2t dt. Then when x equals 8, t equals 3. When x equals 3, t equals 2. And now we have a new integral that is rationalized. So from 2 to 3. So t square minus 1 over t, and then so dx, so multiplied by 2t dt. So t can be cancelled here, and 2 will be moved out of brackets. Okay, so now we can calculate this integral. It's quite easy. So what do we have? 1 over 3 t cube minus t with the substitutions from 2 to 3. So 2 okay, let's move to the next line. So 1 over 3 multiplied by 27 and minus 3, and 1 over 3 multiplied by 8 and minus 2. So 9 minus 3, so 6 minus 8 over 3 minus 2. Minus 2. Plus 2. So 8 minus 16 over 3. And 8 minus 16 over 3 equals, so 8 equals 24 over 3.
But not 8 probably. We also need to multiply by 2.
But, oh yeah, 16, yeah. Thank you for your attention. Yeah, lost it. So 16 over 3 equals 48 over 3. And 48 minus 16 is 32. So the final answer is 32 over 3. And that's it. So as we see, for a definite integral, when we substitute the variable, so we don't have to return to the old variable. So we continue with the new variable and just and integrate. We just modify bounds of integration. So any questions about this exercise? Okay, if no questions, let's have a break. We will meet in 5 minutes. Okay, let's continue. So the next exercise is the following. We need to integrate a rational fraction. So integral from 2 to 3. So dx over 2x squared plus 3x minus 2. Here we need to extract the perfect square, and then we will be able to integrate. Just by accident pressed print screen. Okay. Let's move 1 over 2 out of brackets, so we will have the following. So 3 over 2 of x, and here minus 1. So it will be easier for us to extract this perfect square. So x square plus 2 by 3 over 4x. And so we need to write down, so the square of 3 over 4 plus 9 over 16 and minus 9 over 16. So now it's, yeah, so we can write it in brackets. So now let's continue. So we can collapse it. So x plus 3 over 4, and it will be in power of 2. And here 25 over 16, so minus 25 over 16. And now let's rewrite it as well. So here we have so differential of this expression, so it is equal. And here so it is the square of 5 over 4. So now we need to calculate. So actually, it is this. We have almost table integral. Integral. So the following. So dx over a square minus x square, and it equals 1 over 2 logarithm of a plus x over a minus x plus c, and here we have almost this integral, but we have different order. So here is x square minus a square. So now let's multiply by minus 1. And now we can write down the antiderivative. So 1 over 4 logarithm of this module. So 5 over 4 plus x plus 3 over 4, and by and logarithm of so again 5 over 4 minus x minus 3 over 4, and with the substitutions from 3 to 2, from 2 to 3. Okay. So now Let's simplify it a little bit. First of all. So x plus 2. And here, so 1 over 2 minus x. And then minus 1 over 4. And now let's substitute. So now logarithm over so 5, and here 3 minus 1 over 2, so 3 so 5 over 2. And minus logarithm over 4 and 2 minus 1 over 2, so 3 over 2. So it's done. Now we will use the property of logarithm, so that difference of logarithms equals logarithm over the fraction. So 5 over 5 over 2, and 5 will be multiplied by 3 over 2, and 5 over 2 will be multiplied by 4. So now we can calculate it. So let's cancel first of all this so division by 2. So 3, and here 5. Yeah, and as well we will cancel 5, and we will have 1 over 4 minus 1 over 4 logarithm over 3 over 4. So this is the final answer. And I can write it as difference of logarithms, but do we really need it in this task? Don't need. Any questions about this exercise?
Could you scroll up?
Yeah?
Thank you. No.
Okay, no questions. Maybe anyone else has questions? Okay, if no questions, let's move next. The next exercise, I suggest you skipping L. So, because we will have to spend a lot of time for extracting integer part, but so you remember how to do it. So divide x cubed by this expression, but it requires a lot of time, and we will just receive so again just integration of rational fractions. Now let's move to exercise M, and I will we will remember a little bit method of undetermined coefficients. So we need to simplify this product. So to rewrite these fractions as fractions with, so rewrite it to sum of fractions with these denominators. So the first, okay, b over x minus a plus c over x minus 2a. I don't use a capital because not to confuse the letters. So b multiplied by x minus 2a plus c multiplied by x minus a. Now let's expand. So bx minus 2ba plus cx minus ca. And now let's regroup according to degrees. So b plus c x plus minus 2b minus 2ba minus ca. And now we have the following system of linear algebraic equations. So just two equations. So b plus c equals 0. And this expression equals a. So now let's solve it quickly. Okay. So let's divide this expression by minus a. So we will have 2b plus c and equals minus 1. So cancelled a and it will be easier for us. So now let's find variables b and c. So if I subtract the first equation from the second, so I will have 2b minus b and c minus c. So I will receive b equals minus 1. Then c equals 1. And now I can rewrite the initial integral. So I equals from 0 to a over 2. So minus, oh, no, not incorrect. So minus 1 over x minus a plus 1 over x minus 2a. And now let's integrate. So a logarithm over a module of x minus 2a, we don't know either a is positive or negative, so we don't know about this expression, about its sign. And minus logarithm over x minus a with the substitutions from 0 to a over 2. So now calculating it. Okay, so logarithm over, so logarithm over module so 3 over 2a we have here minus a logarithm over 1 over 2a minus so logarithm over 2a of module of 2a minus the logarithm of module a. So now let's expand brackets, and then we will turn this expression to product. So, and something will be simplified. So minus logarithm of 2a and plus logarithm of a. And we have the following expression. So 3 over 2a, 3 over 2a square. So because multiplying this expression and dividing by, so 1 over 2, 1 over 2 by 2, so a square. So now let's see what can be cancelled. So first of all, we cancel a square, so this expression doesn't depend on a anymore. Here we have 1. So the final answer is the logarithm of 3 over 2. So any questions about this exercise?
No questions.
Okay. Now moving next. So exercise N, let's remember integration rules of integration of trigonometric expressions. So from 0 to p over 2, cosine of x in power of 5 and multiplied by sine of 2x dx. So first of all, so let's modify this expression. Let me remind you this formula: sine of 2x equals 2 sine of x multiplied by cosine of x. And we will use this formula. So 2 sine of x and multiplied by cosine of x. So what I receive? So cosine of x in power of 6 multiplied by sine of x. And actually sine of x is a differential of minus cosine of x. So using differential entry technique here. So done with this transform, and now we can integrate it as a table integral. So minus 2 multiplied by 1 over 7. Okay, minus 2 over 7 just. Minus 2 over 7 cosine of x in the power of 7 with substitutions from 0 to p over 2. So 0 and half of p. So cosine of p over 2 is 0, and cosine of 0 equals 1. but we subtract 1, so we have the final answer 2/7. Any questions about this exercise? Okay, I see that no questions, so moving to the next exercise. And so exercise O, we have the following integral, so irrational functions, function and such kind of irrationality that can be solved with trigonometric substitution that you remember from the previous lesson. For such kind of irrationality, we will use the following substitution. So x equals sine of t, then dx equals cosine of t dt. Then t equals arc sine of x. And when x equals 1, t equals half of p. When x equals 0, t equals 0 as well. So now let's calculate. So let's transform this integral. So from 0 to p/2. So what under the square root? Let's write in details. So 1 minus sine square of t, and this is in power of 3, and multiplied by cosine of t dt. So here we will receive cosine of x in power of 6 under the root. And then when we expand everything, we'll have cosine of x in power of 4.
But not x, t.
Yeah, t. Thank you for your attention. Yeah, don't forget about new variables. Okay, and now we will use formulas of degree reduce. So let me remind you the formula of degree reduce for cosine of a square of cosine. So it equals 1/2, 1 plus cosine of 2t. So doing the same. So here we'll have 1/4 because it will be, because we have power of 4 here. And what do we have? So 1 minus cosine of 2t in power of 2 and dt. Now we will expand brackets, and we will have to use the formula of power reduce again. So 1 minus 2 cosine of 2t plus cosine square over 2t. So now rewriting it. Okay, let's move to the next line. Okay, plus 1/2 and plus 1/2 cosine over 4t. Now rewriting it again. So 3/2. And let's move it to the beginning. So we just added 1 and 1/2. And now let's integrate. So 1/4 multiplied by, okay, let me, yeah, right, substitution. So 3/2t minus sine of 2t and plus 1/8 sine over 4t. From 0 to half of p. Okay, so what do we have? So this signs will be 0, so because sine of p, then sine of 2p, so it will be equal to 0. Sine of 0 is 0 as well. So what really matters us only this addend. So 1/4, then multiplied by 3/2 and by p/2. So the final answer is 3p/16. And that's it. Any questions about this exercise?
Could you scroll up?
Yes, sure. So again, we don't return to the old variable in the definite integral. It makes no sense. So we just modified the bounds of integration. So do you have any questions about this task, the whole lesson, or maybe previous lessons?
No questions.
Okay, so if no questions, let's finish our lesson. Have a nice day, stay safe, and thank you for your attention.
Thank you. Goodbye.
Thank you, goodbye.
Thank you for the lesson. Have a nice day too. Bye.
Thank you.